Now, in this question here, there's an equilateral triangle and an isosceles triangle share a common side BD. What is the measure of the angle ABC? Here now, as you see, we have a BCD, which is an equilateral triangle. That means all the sides here are equal. And in the triangle ABD, we have an isosceles triangle with AB is equal to BD. He asked me now to find the measurement of the angle ABC. So now he asked me now to find the measurement of this angle. Now the angle ABC, it is the angle ABC. Is it the angle of ABD plus the angle of DBC? Is it right? I mean that this triangle, this angle here, okay, this one, this big one here, it contains two angles inside it, two interior angles, ABD and DBC.
Yes, I understood now.
Okay, ABC, this one here, it is the length, it is the measurement. To find the measurement of it, I need to find ABD and DBC. Now, after that, let's find now the ABD first. If you look at this triangle here, which type of triangle here? It is an isosceles. And if this one here is 66, in the isosceles triangle, if the angle of the base is 66, so what is the measurement of the angle in the second one here? I mean, I have two lengths that they are congruent, that they are equal in the congruent in the isosceles triangle. So if the one that is opposite to it here is 66, so what is the measurement of the second angle?
66. It will be equal 66.
It will be
because
66.
66.
So here
isosceles triangle theorem.
Here I'm talking, yes, here I'm talking about the triangle ABD. Now, after that, if here is 66 and here is 66, can I find now the measurement of the angle ABD?
Yes. Yes, you mean AB.
So
yes.
The measurement of the angle ABD is ABD. I want the measurement of this angle. Is what? To find it now, I know that the summation of the angles in the triangle is 180. So 180 degree is the BAD, is the measurement of the angle BAD. I'm talking about this angle, plus this one, which is ADB, plus this angle, which is DBA. Is it right? Yes, grade 8.
Yes, teacher. Yes, teacher.
Okay. Now then, after that, the measurement of the angle BAD, it is 66. plus the measurement of the angle ADB is also 66, and the measurement of the angle DBA is unknown. Both of them, or all of them, they are equal 180. Then after that, 66 plus 66, it is 132.
So equal 48.
Plus the measurement of the angle DBA is 180. So now, then minus 132 minus 132. So the measurement of the angle DBA is, I have subtract now 180, which is 48. So now the measurement of the angle ABD is 48. So this one here, I will write it as 48 degree. Is it clear?
Yes, teacher.
Yes, miss.
Okay. Yes. So now I told you how the question asked me now to find the measurement of the angle ABC. And I told you that the measurement of the angle ABC is summation of ABD and DBC. So, what does it mean?
Teacher, if they shared one side, which is yes, teacher, BD equal 48, or the angle B is 48.
No, the angle ABD. This one here. Okay, it is 48. Because I take only this triangle and I found its angle. So ABD is 48 degree. So what do I need now? I need DBC. I need now to find the measurement of this angle now. Okay, now let's look.
Sorry for it's I was getting because of internet connection.
So what did you want to repeat?
I mean, teacher, does angle ABD, this angle is 48?
Yes,
please.
Yes, it is 48 because only looked at this triangle here and analyze it and found ABD, which is 48. Okay. Now, after that, so then because of that, now I told you, sorry. So because of that, now I told you that if I need now ABC, I need ABD plus DBC. Where is the angle DBC? It is inside this triangle. This is the angle here. So I am remove now this triangle and I would write it here as C, B, D, and here is my angle. I want to find it. But here, what is the type of this triangle? It is an equilateral.
Equilateral.
What does it mean by equilateral? That means all the sides and all the angles are equal. So every time, anytime, what is the measurement of the angle in the equilateral triangle?
Miss, I forgot. I mean, okay. 130, 180.
The measure, no, let's see. The measurement or the summation of the measurement of any triangle, it is 180. If I told you that this is x, all of them are the same. So if you name this one with x, and this one with x, and this one with x, because they are the same. If it is A, 1, 1, 1, 2, 2, 2, 5, 5, all of them, it must have the same measurement. So if all of them are x, so you will say it is x plus x plus x. And x plus x plus x is what?
X to the power of 3.
No, it's not multiplying, it's adding.
180.
3x. No, I mean if you add x plus x plus x, it's 3x. Equal 180. Divide by 3, divide by 3. So what is the measurement here? Oh, the answer here, it is 60. So all the time, or any time in the equilateral triangle, every time, okay, the measurement of the angle is 60.
Okay.
You have any equilateral triangle, and I'm asking you, or I asked you, what is the measurement of its angle? You will tell me it's 60. So here it is 60, and here it is 60, and here it is 60. They are equal. In the equilateral triangle, all the angles are the same, which equals 60, and all the sides also are the same, but here it's not have a fixed number. It may change, but the angles, it have a fixed number, which is 60. Here also, in the rectangle as an example, which we know that the summation of the angles in the rectangle is 360. So what is the angle here? What is the measurement of each angle? They are
90 if it was.
Yes, they are 90. Well, how, from where we bring this 90? If you divide 360 by 4 angles, you will have, what is, if you divide 360 by 4, what you will get?
90.
90. That's why from where we bring this 90. And here also the same. The summation of the angles in the triangle is 180. And we have 3 angles. If you divide 180 by 3, you will have 60. So because of that now, the measurement of the angle DBC is 60. So what is the measurement now?
The measurement is 48 plus 60 equal 108.
Thank you. I want now the measurement of this one, the big one here, which is ABC. I want the measurement of this angle. As I told you, it is a summation of ABD plus DBC. ABD we found it as 48, and DB here is 48, and here is 60. So the summation of them is 106. And this 106 is a summation, is a measurement of the angle ABC.
Miss, it's 108 or 106?
No, 108. I said 108 and I wrote 106. It is 108.
Teacher, this is only the angle is equal 108 ABC,
yes,
but not the triangle. Yes.
Which triangle?
This, the big one, ABC, all the triangle, is not 108. Only the angle ABC.
Oh, yes, the angle, yes. It is only the angle ABC. It is 108.
And teacher, and teacher, yes, for the rectangle here, this is equilateral rectangle.
You mean ABCD?
Now this rectangle that you made it, that the summation of that rectangle is 360, and you said 90, 90, 90, 90. So this rectangle is equilateral?
No,
because not
have the same angle, but not the same sides.
if there is any triangle, that rectangle, I mean, have the same side angle
Must have the same angle. Here, you see, I will give you something here. It's out, it's not in our lesson, but okay. Every time, if you need to find, I told you that this shape, it has an equal angle, like as an example, triangle, square, rectangle. Imagine that I want to make it as a pentagon, sorry. Okay, now only the triangle, its angle is 180. But if it has 3 sides, it has only 180. If it has 4 sides, 5 sides, 6 sides, and so on, the summation of the angle is 360. Only, all the shapes in our life, the summation of them is 360, except the triangle, which is 180. Okay, now, to find now the angle, if I told you that the angles here are equal, so what does it mean? Here I have 180. How can I find it now? I will say the 180, I will divide it by 3, I will get 60. So the measurement here of each angle are 60, 60, 60. Now look at the square. The summation of the angles of the square is also 360. How many angles in the square?
4.
4. So you will divide 360 by 4, you will get 90. So because of that, the square also, it has an equal angles, which are 90. On the rectangle, I mean this one now. In the rectangle, all the angles are equal to. What is the measurement of each angle? It is 360 divided by how many angles here? We have 4, and you will get 9. 4. Now look at the last one here. In the last one, how many angles you have for the pentagon?
5.
5. So you will divide 360 by what?
5.
By 5. You will get 72. This 72 is the measurement of each angle.
Teacher, I'll make this step like 360 divided by a number. If you told me that all... okay.
Yeah, like 360 divided by n, where n is the number of angles. By that, you can find the measurement of any shape that has an equal angle. And for the equilateral triangle, it is 60. Is it clear now?
Okay. Yes. Teacher, and I can make it with the sides, like 180 divided by 3 sides, or only for angle?
No, the 180 is only the summation of angles. But the sides, no. It could be 6, 6, 6. It could be 4, 4, 4. But if you know the measurement of any side, you can know the measurement of the other sides. I mean, sorry, if you know the length of each side or any side, you can know the length of the other sides. But here, all of them are 60. If the sides is 4 or 6.
Yes. Okay.
The angles are fixed. But the sides, no. But in the isosceles triangle, if I told you that this is 40, this one, it will be 42. They are equal. But And if I told you this is 5, you tell me that this is 5. But for this one, it's not equal 40. If it is 40,
you must find it.
You have to find it, yes.
Okay.
Okay, now. Now, here now we will talk about corollary. What are the corollary? It is a theorem that can be proved easily using another theorem. So you can say it is a reason in a proof. Yani, I mean that a corollary, it is a result of theorem. We talked about many theorems in this lesson. We talked about this one, that if AC and BC are congruent and the angles are equal, so CD is perpendicular on AB. And we talked about also this one. If AB is congruent with AC, with congruent with B, so AC is congruent with BC. And we say that also if AC is congruent with BC, so the measurement of the angle A is equal to the measurement or congruent to the measurement of angle B. These are the theorems that we talked about them. Here now we will talk about a corollary. A corollary, it is a theorem, okay, but it is a result to the previous one, like here. This one, if you go back to the theorem 4.3, where's 4.3? It is this one. Here it is a result, or it is a theorem, or a result of this theorem. In this one here, we say that if AC is congruent with BC, so their angles will be what? Will be congruent. And also, if, so I was talking about two sides. If these two sides are congruent, so their angles will be congruent too. Here now, he talked now about three sides. If these three sides are congruent, like this one here, xy and yz and zx, if all of these sides are congruent, so their opposite angles will be congruent too. I will show you here how. In the 4.3, in the theorem 4.3, we say that if you have this side, here we have its opposite angle. And if you have this side, here we have its opposite angle. And we say that if this side AB is congruent with CB, if these two are congruent, so their angles will be congruent too. Is it clear? That we said before. Yes, grade 8.
Yes.
Yes, teacher.
So if they are, these two sides are congruent, so I can say now these two angles will be congruent too. In this corollary here, we will have the same. But what? In this theorem, in the first one, we deal with an isosceles triangle. In this one here, we will deal with equilateral triangle. Here now, I'm talking about equilateral triangle. What is the meaning of equilateral triangle? That's all the sides are equal. Now, I want you now to look at this side. For this side, it has this angle. And for this side, here you have this opposite angle. And for this side here, this is its opposite angle. Is it right?
Yes, teacher, this is in the equilateral triangle.
Equilateral triangle. Now, here now, if all of the sides are congruent, if all of the sides are congruent, can I conclude now that all the angles are congruent?
Yes,
Yes,
because
teacher.
this corollary.
Because it is equilateral. Because it's an equilateral triangle, all of them are equal.
Yes, so this is now our corollary. It is as the same as 43. It is like a result of this theorem. It is a result of this theorem. In the theorem 43, we say that if you have two sides that are congruent, so their opposite angles will be congruent too. In this theorem here, which is a result of a theorem 43, but here we are not talking about two sides, we are talking about three sides. If these three sides are congruent, so their angles will be congruent too.
So teacher, if we want to make a proof and we found like you give us an equilateral triangle, so we have to write what? Yani, their three sides are congruent, so the three angles are congruent. So what I will write? I'll write corollary to theorem 43.
No, it has the look at here. Yes, you can say it is a corollary to the theorem 43.
Okay.
Okay. Now look at the second. So if the triangle are equilateral, so the triangle here it will be ecta or equiangular. That means if it has and three sides are equal, so its three angles will be equal to. Now look at the fourth one here. Oh, sorry, the second one. It's a result of 4, 4. Here now, in this one, if you have now talking about the second theorem. In the second theorem, we say that if we have this triangle now, and I told you that this angle is opposite with this angle, and this angle is opposite with this angle. Okay, this angle is opposite with this one, and this one is opposite with this one. And I told you now that this angle is equal to this angle. Can we conclude that these two sides are congruent too?
Yes.
Yes, teacher.
According to the theorem 4, 4. Here also the same, but in the 4, 4 we talked about an isosceles triangle. Here I'm talking about equilateral triangle. If you have in the equilateral, all of us know that we have an equal angles. What does it mean? That means
It means
if this
equal
is my
sides.
angle, if this is my angle, it's this one, it will be its opposite side. And if this one is my angle, this will be its opposite side. And if this one is my side, so this will be, oh sorry, if this one is my angle, this one be its opposite side. Now, if I told you now all of these angles are congruent, can I say that all of the sides are congruent?
Yes.
Again, teacher, can you repeat the question?
If I say that all of these angles are congruent, can I say that all the sides are congruent?
Yes.
Yes.
Yes, teacher.
Like 4, 4. In 4, 4, I'm talking about only two angles. In these two angles, if they are equal, so its sides will be equal to. Here we have 3 triangles. In these 3 angles, if they are congruent, so their opposite side will be congruent too. So if a triangle is equiangular, if they have all of the angles are equal, so all of the sides will be equal too.
But teacher, this is the definition of an equilateral triangle
Yes, but here
that have.
yes, but in here it's written as a theorem.
Okay.
Now, look at this one here. Finding in this problem, we will find the angle measures. What are the measures of angle A, B, and ADC? Here now, as you see, we have here now we have this triangle. It is D, C, E. And we have this triangle. It is ADE. And we have another triangle. It is ECB. Now, he asked me now to find the measurement of A, to find the measurement of B, and ADC, this angle now. And he told me now that all of the sides are equal. What does it mean? Look at the first triangle here. If you look at
It means that all the angles are equal.
Thank you. So look at the triangle ADE. ADE. This angle, it will be what? As I told you before.
60, 60, 60.
It will be 60. Thank you. Look at CDE.
It will be 60, 60, 60.
60, 60, and 60. Now, look at the triangle CEB. Here is what now? 60, 60, 60, 60, 60. Thank you. Now, he asked me now about the measurement of the angle A. What is the measurement of the angle A?
Measure is 60.
It is 60. I have this here. What is the measurement of the angle B?
60.
It will be 60. Now, what is the measurement of the angle A, D, and C? ADC, this one. The big one.
Is also 60.
Look at here now. This one. ADC, this one, the big one. Now, the measurement of the angle ADC is equal the measurement of the angle ADE. Is it right? ADE yes. And EDC. Is it right? This
yes.
angle, the big one,
Yes,
it has two angles inside it. The measurement of the angle ADE is what? What is the measurement of ADE?
60.
60.
60.
And EDC
is also 60.
60. So what is the measurement of the angle ADC now? The big one.
120.
180.
Is it clear?
Yes.
Yes, teacher.
Yes, miss.